Hey everyone, and welcome. Today, we're going to dig into two of the most fundamental movements that shape, well, everything in our lives, from your morning coffee to the seasons changing right outside your window. Let's pull back the curtain on the cosmic clockwork that dictates our days and our years. I mean, have you ever really stopped to think about it? These massive planet-wide changes happen so reliably, like clockwork. But what's the actual engine driving it all? Well, the easiest way to picture it is to think of our Earth as a celestial dancer. It's pulling off two incredible moves at the very same time, a spin and a grand circle. And these two dances, rotation and revolution, are responsible for the entire rhythm of our lives. Okay, so let's get right to it and break this down. On one side, you've got rotation. That's our planet's daily spin on its own axis. It takes about 24 hours and boom, you get day and night. On the other side is revolution. This is the big one, Earth's year-long journey around the sun, which gives us our seasons. Simple, right? Two different moves, two totally different results. All right, so first up, let's zoom in on that daily spin. It's definitely the faster of the two dances, and it's the one we feel most directly every single day. So what exactly is rotation? It's pretty simple, really. It's just the Earth spinning around its own axis. You can think of that as an invisible pole going right through the planet from top to bottom. One full spin takes roughly 24 hours, and that, of course, is what we call an Earth day. It's our planet's most basic timekeeper. And you know what's so cool about this? This is not a new idea. The ancient Indian astronomer Aryabhata laid this profound truth out centuries and centuries ago. It just goes to show you, humans have been looking up at the sky and figuring this stuff out for a very, very long time. Now, this constant spinning has a really simple but profound effect. As the Earth turns, only half of it can be lit by the sun at any one time. That's daytime. The other half is in its own shadow. That's nighttime. And that dividing line between light and dark actually has a cool name. It's called the circle of illumination. Think about it. That line is always moving, sweeping across the planet, giving us sunrise and sunset. Okay, so we've got the daily spin down. Now let's zoom out and look at the bigger picture, that huge yearly journey. This is the second, slower, and much grander of Earth's two dances. So revolution is the movement of our entire planet as it goes around the sun. And here's a key detail. The path it takes, it isn't a perfect circle. It's actually an ellipse, so it's a little bit of an oval shape. This fixed path is what we call Earth's orbit. Now, to finish one full lap around the sun, our planet takes 365 and a quarter days. And that little leftover quarter of a day, you might think it's no big deal, but it's actually super important for how we keep track of time. So how in the world do we deal with that weird quarter day? Well, the solution is actually pretty ingenious. For 3 years in a row, our calendar just ignores it. But then on the fourth year, we collect those 4 lost quarter days, add them all together, and what do you get? One full 24-hour day. And that, my friends, is a leap year. It's a year with 366 days, because we pop that extra day into February. It's a simple little calendar hack that keeps us perfectly lined up with the Earth's real journey around the sun. Without it, our seasons would get totally out of whack over time. Okay, but here's where it gets really interesting. Just revolving around the sun isn't enough to give us summer and winter. There's a secret ingredient, a crucial detail about our planet's posture, you could say. See, if the Earth just went around the sun sitting perfectly straight up and down, we wouldn't really have distinct seasons. The weather would be pretty much the same all year round. So the journey itself isn't the full picture. Something else has to be going on. And this is the secret ingredient. This number right here. The Earth's axis, that imaginary pole it spins on, isn't straight up and down compared to its orbit. It's tilted, making an angle of 66.5 degrees with its orbital plane. You know, that flat disc-like path it travels on around the sun. This tilt changes everything. And this is the absolute key to the whole thing. As the Earth makes its huge journey around the sun, that tilt doesn't wobble or change. It stays locked, stubbornly pointed at the same spot in deep space the entire time. And that constant, unchanging tilt is the real secret to the seasons. So let's connect the dots. How does this tilt actually make the seasons happen? Well, for part of the year, a hemisphere, let's say the northern hemisphere, is tilted towards the sun. It gets blasted with more direct, concentrated sunlight. The days get longer, things warm up, and we call that summer. Then, 6 months later, that same hemisphere is tilted away from the sun. It gets weaker, more spread out sunlight, the days are shorter, it gets colder, and that's winter. So this tilted journey our planet takes, it's not just a smooth, gradual change. It actually creates 4 really special moments during the year, moments that people have been marking and celebrating for thousands of years: the solstices and the equinoxes. So the solstices, think of these as the extremes, the most tilted points of the year. Around June 21st, you have the summer solstice, when the northern hemisphere is tilted as far towards the sun as possible. That gives us our longest day of the year. The exact opposite happens around December 22nd with the winter solstice, our shortest day. And of course, when it's winter for us, it's summer for the southern hemisphere. Right, but what about those in-between moments, the points of balance? Well, that's where the equinoxes come in. These are the 2 sweet spots in Earth's orbit where our planet's tilt is perfectly sideways to the sun, meaning neither the North Pole nor the South Pole is tilted towards it. These happen around March 21st and September 23rd, and the equinoxes are basically the great equalizers of the year. On these 2 days, the sun's most direct rays shine right on the equator, and because of that, day and night are almost exactly equal in length all over the entire planet. They mark the official start of spring and autumn. Whew, okay, that was a lot of cosmic choreography. We've covered the spin and the journey. So let's zoom back in and wrap this all up so you know exactly how these dances work together to create the world we live in. So here's what you really need to remember. Number 1, rotation. That fast spin on our axis is what gives us our 24-hour cycle of day and night. Number 2, revolution. That long, year-long journey around the sun is what defines our year. And number 3, the real secret sauce, that constant axial tilt, which works together with the revolution to give us our beautiful, predictable cycle of seasons. And that leaves us with one last thing to think about. Just imagine for a second a world without that tilt. No seasons, just a permanent, unchanging climate wherever you lived. How different would our entire civilization, our history, our food, everything be? It really makes you appreciate the incredible, elegant mechanics of our dancing planet.